we have dooms, okay, in our structures. Then how can we determine the quantity of doom? Because in order to determine the quantity of doom, what we look for is actually, let's say this is a doom, okay, and let's say this is RCC doom, okay. It means there are almost four, okay, let's say cement, and then fine aggregate, coarse aggregate, and then of course steel, okay. These four things are being used in the same doom. It means we have to determine these three materials, okay. Now in order to determine these four materials, sorry, we need the volume of the same doom, okay. It is very important. Now you cannot determine the volume of a doom just by simple formula, okay. You have to do some, like, maybe other steps, some mathematics, you can say, okay. Let's just consider from the basic a ball, you can say, like this one, okay. Because doom can be half of the ball, maybe it can be segmental, okay, segment, it can be half, okay. There are different types of the doom. Now the volume of a ball, it is already just covered from the previous video. In the previous video, maybe in a class, it is actually 4 by 3 and pi r cube. Now r is actually the radius from this point till that, okay. If I just change the color so you can see it, okay, this is the radius. As you can see, if the sphere or the ball, if it's hollow, then how can we determine its volume? It's hollow. Like maybe you can say, this is solid, this one. What if it is like maybe hollow? How can I represent it? Okay. Maybe let's say if we have half section like this one, okay, and let's say this section, the remaining one, this is solid, okay. So this is just half section. As you can see, this is hollow. Inside, it is just, you can say, empty. So then we can, of course, determine the same volume. You can say we're going to subtract the internal, okay, volume, the inside volume, like this red shaded, from the external one. So it means the spare volume, if it's, you can say, hollow, it must be 4 by 3, which is the same thing, okay, and then pi, and we will just subtract the inside radius, you can say, r cube minus small r cube. The capital R, that is actually the radius for the external, you can say, surface, like that. And the small one, that is actually the radius for the internal, you can say, this guy, okay. And further, the surface area must be, if you remember, 4 times pi r square, or maybe pi d square divided by 4, okay. All right, now next, as you can see, it is very complicated to determine the quantity of a segmental doom. Like maybe we have types of doom. Let's say this is a whole circle, and let's say we have just split it into two, okay, equally. It means this is semi circular doom, you can say, okay. What about segmental? Let's say this is a sphere, and segmental, okay, semicircular, it is very important. Most of the students don't understand it, okay. A semicircle is actually, you have to look to the chord, okay. Let's say if I have some doom like this, okay, and this is 10, it's, you can say, chord, and then the rise, let's say this is 5. How can I confirm if it's semicircular or maybe if it's segmental, okay? As you can see, this is 5 units. This can be radius. It's simple. It means this is just semicircular. However, if here we have another doom, let's say this guy, and let's say this is 10 feet maybe, or 10 meter, and let's say the rise, that is just only 1 feet. It means the circle may form the same way like this, okay? The chord is not just passing the same way like this one, okay, from the center, okay? It is just maybe above the center. So it means this is just segmental. And we have different formulas for both. Okay, let's just consider an example, okay? So you can understand it better. Let's say we have a doom like this. We will just have an example, okay? And I think this example is very good to understand this thing better. Let's say we have a doom like this one. And it is, you can say we are just informed that the thickness of the doom, that is just T, and let's say that is 6 inches. You can have the same example in MKS system. Maybe you can say in metric system. This time I'm taking inches, no problem. All right. And then let's say it is known that the span, okay, span is actually the distance between two supports. Okay, if you remember it. And that is, let's say, 14 feet. And then we have actually the height of the same dome. Okay. And I'll take that internal. Let's say the internal height that is 7 feet. Okay, what do you see? It means the dome is just semicircular because the rise of it is just, you can say, half of its span. It means the span can be the diameter. Okay, so we can say that is just the radius, okay, which is 7 feet. Now, if you remember, a solid dome can be actually 4 by 3 pi r cube. But this time it is, as you can see, hollow. It means we can use 4 by 3 and then pi, and we will just subtract the internal radius, you can say. You can say the capital R cube, you can say, and then minus the small r cube, okay, to make things little bit easy. Okay, now the capital one, I'm gonna say the capital one can be, let's say this is the small one, the internal one, and for the external one, I'm gonna say this is, you can say, capital R. And that can be actually the small r plus the thickness, you can say this thickness, which is 6 inches, okay? So it means the capital R is now 7.5 feet because we have added 6 inches over there, okay? So let's just do it. You can say the volume of the dome can be now 4 by 3, then pi, remember pi is just 22 by 7, 22 by 7, okay? And then the capital R, that is just known, which is 7 by 5, 7.5. We're going to put that value over there. And there is remaining one thing, which is cube actually, okay? We will subtract the internal, which is actually this thing, and that is only 7 cube, okay? You have to do some mathematics. You can get the volume. Maybe if I use my calculator, let's say, okay, where is my mobile? It's over here, okay? Okay, it's almost 165 point maybe or 195, okay, cubic feet, because all these dimensions are in inches, maybe in feet, okay? That's why the volume unit can be in cubic feet, okay? It's very simple. There is nothing complicated over here. So this is how we can determine the volume of a dome which is semicircular.